Hello everyone, welcome to the course on data structures and algorithm. In this video we are going to see binary search. So in previous video we saw linear search. So linear search was a very simple concept wherein the data is given and all you need to do is keep searching from first location to last location, right? So this is, for example, an array having 8 elements. All right, and there are some elements like 11, 22, 0, -6, something like this, and you start searching from this position and you go all the way to this position. So this is the linear search, the simplest one. The benefit of linear search is the elements are not required to be sorted, so sorting is not required. All right, but disadvantage, sorting is not required, but disadvantage is it is taking little more time. So it's a more computation time, because if you are looking for something and which is available at the end, in that case you will have to search through entire list. So it is require more computational time. So now there is another searching technique, that is binary searching technique. All right, so in binary searching it requires less time compared to this linear search. But there is a condition to search using this technique, binary search technique. The elements are required to be in sorted form. So over here sorting was not required, but in this case sorting is required. So binary search works if the elements are already in sorted order, like -7, 0, 3, 15, 12, 20, 89, 199 and 2000. So you can see this is a sorted array, sorted list. So if this is the case, binary search is applicable. In random number, in unsorted way, binary search is not applicable. So now let us try to understand how does it work. So for this, supposing an array is given having, let's say, 14 items starting from 0 to all the way up to 13. So there are total size equal to 14. All right, and the indices are, suppose this is your start. So start is equal to 0, and this is your end is equal to 13, or end equal to size -1, or is equal to 13. Now supposing you are looking for 39. So how you are going to search in case of binary? If it was linear, we would have started in this way, but this is binary, and if you carefully look at this array, you can see that all elements are in sorted form. So starting from the lowest to all the way up to highest in the end. So what do we do? So this is our start and this is our end. So if I erase this, so start is 0 and is 13. So 13 is nothing but my size -1. And now we are going to compute middle. Middle is nothing but average of start and end. Sorry, this should be end. All right, so start is equal to 0 plus middle, that end is equal to 13. So 0 plus 13 is 13 divided by 2. So actually it is 6 point something, but because this is integer division, you will get 6. So for this, for start equal to 0, end equal to 13, you are going to get middle equal to 6. Now compare this element that you are looking for, that you are searching for, with this element 27. All right. So now when you compare these two things, there are 3 different possibilities. For example, when we compare x with a of middle, there are 3 different possibilities. First is, if both the things are same, then you have found the element. If this is 39, then done. But in our case, this is not the case. Now if x is less than a of middle, x is 39 and a of middle is 27. So 39 is less than 27. So no, this is false. All right, so we are not going to see, but this can be a possibility. And third possibility which is applicable to us is 39 is greater than 27. Yes. So in that case, we know that 39, because all the elements in this direction will be less than 27. So there is no point in searching. So we will not be looking for this, but we will be looking for this only. So in this case, what we'll be doing? So we will restrict our search. We will restrict our search in this only. All right. So we are going to change now start. So start will be now what? Start will be now middle plus 1. Start will be now middle plus 1. And accordingly, end will remain there. And we'll be doing, again start plus end divide by 2. Something like this. Alright, and if this is the case, supposing our x instead of 39, it is just, let's say, 9. So in this case, we will be looking for these elements only. So now let us take an example. Alright, so this is the situation. Start is pointing to the 6th, which is the 0th element. End is pointing to 77, which is the last 13th element. And then middle is equal to 0 plus 13 divided by 2. So middle start plus end divided by 2, that is 6. And we are looking for 39. So when we compare this, compare 39 with 27. So compare 39 with 27. What will happen? 39 is equal to greater than 27? Yes. So in that case, what we'll do? We will not, because if this is greater than, so we will be looking for this item only. So we will not be looking into this item because 39 cannot be over here. So what we are doing? We are moving start. So start is now middle plus 1. Start is now middle plus 1. What is middle? Middle was 6. So 6 plus 1, that is 7. So now start is pointing over here and end is at the same place only. So with this new start, that is 7. So 7 plus this end 13 divided by 2. So now 7 plus 13 is 20. 20 divided by 2. So new middle will be 10. So new middle will be 10. Alright. So this is the situation. This is the new middle. Now let me erase everything. So now you can see. Now the new middle is equal to 10. Now again compare 39 and this 47. Again compare 39 with 47. So 39 is less than 47. So should we look for this place? No, because these are all higher values and we are looking for something which is less than 47. So now we'll be looking into this stuff. Alright, so in this case, what we will be moving? We will be moving our end position. And end position will be middle minus 1. So now look at this. Now the end, so start is same thing, but end is middle minus 1. So now this is my new end. So now I'll be restricting my search in this array only. So between 7 to 9. And now new middle will be 7 plus 9 divided by 2. Because every time we calculate start plus end divided by 2. So what is start? 7. What is end? This 9. End equal to 9. Alright, so 7 plus 9 is 16. 16 divided by 2 is 8. So new middle will be 8. So now look at this. So now if I see, now this one is start, this one is end, and this one is middle, new middle. Now compare this new middle with this one. So you can see both the things are same. So if both the things are same, you found it. Alright, so we have found it. Just in 3 comparison, just in 3 first comparison, second comparison and third comparison, we found our data item. If it was a simple linear search, we would have searched 1, 2, 3, 4, 5, 6, 7 and 8 and 9. On 9th search, you would have found this X in case of linear. But now in case of binary, this is the benefit of binary search. Just in 3 comparison compared to 9, just in 3 comparison, we are done. We found the element. Alright. So this is the algorithm. We are passing 3 things: the data item, the list, then the size, and what you are looking for, the search item. All right, what you are looking for, the search item. So we are going to pass 3 things. All right, and now start is equal to 0, end is equal to size minus 1. So just like this. So something like this. This is your list. All right. So initially start is equal to 0. Start equal to 0. If there are 8 elements, then end equal to 7. So end equal to 7, size minus 1. And then we just repeat a loop. with middle equal to start plus n divided by 2, and we compare a of middle with that item. And there are three things. If it is equal, then we found it and we simply return the middle position. If it is greater than, we change the end position, we move this end over here, and if it is less, then we move start. So simply just keep on doing, and at the end, if you do not find this one, we will be returning -1. So -1 is not found situation. So let us see the program of this binary search. So you can see in our main, I have one array with these 14 elements. So 14 is size, 39 is something that you are looking for. Alright, so 39 is something that, and this is in sorted order. So as we know, it is our prerequisite condition. If the data items are not in sorted order, you cannot, apply this binary search algorithm. So now we are calling this binary search algorithm, search binary. So we are passing the array. Now we are passing the size is 14, we are passing the size, and we are passing the search element. So search element is 39, means we are looking for 39 in the array. Out of this many elements, is 39 is there or not? So we are looking for that. So again, we have used these three handles over here, three variables. Start is equal to 0, end equal to size -1, and middle we are going to compute. And then we are running a loop. While the start is less than or equal to end, we are computing middle equal to start plus n divided by 2 and checking that a of middle equal to x. If it is the case, we are returning the position. So that position will be written into this variable. But if it is not the case, then there are two options, whether a of middle is greater than x. In that case, we will be moving the end position. In that case, we will be moving the end position, something like this. Initially end was over here, but now we'll be moving end over here. So initially end was over here, but now we will be moving end over here, because we want our search to be restricted in this place only. Alright, if this is not the case, the other way around. In that case, we will be moving our start pointer. So if start was initially over here, but if you don't find something over here, then we'll be moving start to this position, middle plus 1, and just keep on doing. So this is how you will get a complete output, the complete execution of this binary search algorithm. So thank you guys for watching this video. In our next video, we are going to discuss about hashing techniques. Thank you.